use tool 5, we use height offset 5. The D represents diameter offset. So if you're using tool 1, what D value are you going to use? Diameter 1. If you're using tool 5, you'll tell the machine diameter number 5. Okay? So in the program, you do not tell the machine how long the tool is, you tell the machine where to find it. The same thing applies for the diameter. You don't tell the machine the diameter of the tool, you tell it where to find it. And you're going to input those numbers on the offset page. Okay? So once we go over this, we'll go out to the simulator and I'll show you where that is located. Okay? So again, the actual offset amount must be input in the tool offset display number. You do not put it in the program. On the Haas machine, you have 200 different tool diameters that you can use. Usually, you have one cutter offset for each tool. Highlight the next sentence. It is best to use the same offset number as the tool number. Tool 1, H1, D1. Tool 2, H2, D2. Keep it simple. If you wanted to, you could use tool 1, height offset 5, diameter offset 10. But now what you're going to do is create confusion. So keep it simple. Tool number, height offset number, diameter offset number should always match. 111, 222. Okay. On the Haas tool geometry offset display page, the two columns to the right side of the display are for your cutter diameter offsets. The geometry column in the offset display is to set your initial offset value. It can be defined as either a diameter or a radius. The selection you choose will be listed at the top of the offset geometry column, so you can change it. We'll go out to the machine in a second and I'll show you how to change it. But most of the time you want it on diameter. And I'll explain why when we're at the machine. Highlight this next part, the where column. To the right of the tool geometry column is for any adjustments you need to make. So you use the where column to make any adjustments you want to do. And the machine will take these two values, add them together, and use the one value. Right? So let's go to the machine. I'll show you where these offsets are located, and we'll talk a little bit about programming. Right? So you can leave your jackets and everything on.
You got the coronavirus. You got the coronavirus.
We all got it. But we're gonna make it. Corona nothing. No, it's already 9 something, dude.
So when we go to the offset page, you've got two offsets. You've got the work offset and you've got your tool length offset page, right? So we said earlier we're going to go to G54 and we're going to add some Z's. So here is where you'll put the negative 5 thousandths. That will drop all the tools down an extra 5 thousandths. Not just the fly cutter, every single tool. You press offset again, we've got a length. That's where you press your tool offset measure, and I'll put the number for you. To the right of that, we've got diameter. This is where you tell the machine the diameter of the tool. So in our program, tool number 4 is where we need to put the diameter. So you're going to come down to tool 4, and what number are you going to put? 250. Now the machine knows where to find that value. So you'll put D04 in your program, and the machine will call up that number. Right? The where column to the right is where you make any adjustments. So if your part comes out oversized, you measure that 4-inch dimension and it's oversized, you just put in a minus number. And the machine will take off another 5 thousandths if you run the tool again. So you don't have to adjust anything in your program. You just adjust the where, and the machine takes control. Right? It's a very powerful tool. The majority of programs out there in the industry use G41 and G42, so you got to understand how to use this. Right? So before you set your tool up at the machine, what should you do to it? How do you know it's 1/4 inch?
Measure it.
You need to measure it. When you measure it, what kind of measurement are you getting? You're getting the diameter. That's why it says it's best just to leave it in diameter. When you take your measurement, you put the number in. You're done. The old tool there, whereas they used to have it in radius. When you go to the offset page, now it's in radius. So you have to measure your tool, divide it by 2, and then enter the number. The more math you're going to do, the more likely you are to make a mistake. That's why it's best just to have it in diameter. Whatever you measure is the number you input. Right? So it is possible to change it, but it's a lot easier to work in the diameter page. Right? Do not forget to put the diameter value. If you put D0, how much is the tool going to compensate? Nothing. You just scratched off your part. Right? So always double check that you set that D value if you need it. Right? Any questions how to set it up at the machine? Let's go back in the classroom, we'll talk about how to program.
Oh, I gotta plug up my phone.
Turn over the page and handout. It says credit compensation can be simplified if you have a basic understanding of manual machinery. There are 2 common types of cutting conditions. What are they? Climb and conventional. What kind of cutting are we supposed to do on the CNC? Climb. There is no backlash to worry about. Always try to climb cut. So, if the programmed cutter path needs to climb cut, which is what's usually desired on CNC machines, since the machines are rigid enough to handle this type of cut, and the conditions from this type of cut are usually preferred, highlight this part. It will then be programmed with G41. So in order for you to climb cut on a CNC machine with a right-hand tool, you've got to use G41. If you're using G42, what are you doing?
Right hand.
You're conventional cutting.
Oh,
That's not what you're supposed to be doing. You're supposed to use G41. So if you need to put G42 in your program, you've done something wrong. You're moving the tool the wrong direction. You're going to conventional cut. You're supposed to climb cut. So turn over the page. You've got an example there. Looks a little bit like the clamps that we did, right? When you machine around the outside of a part, you have to go clockwise direction. When you machine on the inside, a hole or a pocket, you've got to go counterclockwise. Right? So climb and conventional cut with cutter compensation. This refers to the direction of cut relative to the direction the spindle is turning. In CNC milling, it is common practice to climb cut. So if the spindle turning clockwise, as it usually does, highlight this. Cut a contour. Cut the profile or the outside in a clockwise direction. So contour, some people might call it a profile, or the outside of a part. Clockwise, G2. Got to go in a clockwise motion around the part. Highlight the next part. If cutting a pocket or a hole, cut counterclockwise, G3. You have a part. That's your end mill. And you move to this position here, and you program G41, because you want to climb cut, and you go this direction.
Clockwise.
Where's the tool going to be?
To the left of
To
the.
the left of the line as it goes around. What just happened to your hole?
It's too big. It's too big.
It's way oversized. You just scrap the part. But if you change the direction and now you go that direction, where's the tool going to move this time?
Inside that.
Inside. That's exactly what you want the machine to do. Right? It is critical you understand which way you're moving the tool. Left and right. It's a big difference on the direction that you're facing. This is my left hand. To you it looks like right. Right? So let's take a look at the back page. Some critical things you need to understand before you program. So some restrictions with cutter compensation. Cutter compensation command must be on the same block with an X and or Y. Highlight that. A cutter compensation command must be on the same block with an X and or Y. You can't just program G41 and the machine starts compensating. It doesn't work like that. Back page.
Oh, there it
Number
is.
1. You have to program G40, G41, or G42 with an X, a Y, or both. When moving onto or off the part using cutter comp, highlight the next part. You cannot, it does not work if you try to turn it with a Z axis move. So if you put G41Z, nothing happens. Guess what happens next? You just scrapped your part because you didn't do the compensation correctly. So when you activate or you deactivate, you have to do it with an X or Y. You can never use a Z. All right? Restriction number 3. You cannot, it does not work if you try to do cutter compensation with a G2 or G3 move. So you can't put G41, G2. It does not work. You have to use G01. So whenever you activate cutter comp, has to be with G1.
Or G00.
But if you G0 onto the part, what's going to happen to your tool?
Oh, yeah.
You're going to crash the tool. So just use G1. Forget about G0.
Because you're going to cut through.
You're going to wrap it onto the part.
Right.
What just happened to your tool? You broke it.
Breaks.
G1, you're going to cut into the part, which is
Right.
exactly what you want to happen.
Right.
So when you activate cutter comp, highlight the first sentence, select a clearance point. You need the tool to be away from the workpiece. So select a clearance point without cutter compensation to a start point in the X and Y at least half the cutter diameter away from the part. So position 2 is on the part. What is the Y value? Part's 1.5 inches wide, so that is 750. We start the tool at Y 1 inch.
Wow.
So how far away from the part is it? 250. This is telling you it needs to be at least half of the tool. What size is our tool? 250. So what's half of the tool?
125.
125. We're more than 125. We're good, right? It needs to be at least 125 away from the part.
At least.
More is better. You've got clearance. So always start the tool off the workpiece. Highlight all of number 2.
Do not cancel cutter compensation on any line that is still cutting the
When
part.
activated. One up. You're highlighting the wrong one.
Number 1.
When activated, you're looking at deactivated.
Oh, bring the Z-axis down.
Always bring the Z down before you activate cutter compensation. So you're going to move to the clearance position. You're going to bring the Z down. Now you can activate cutter compensation. Don't activate it and then bring the Z down. It doesn't work correctly. So always bring the Z down first. Number 3, highlight the first sentence. When you make an X and or Y-axis move, the G41, you need to tell the machine what diameter you want it to use. So you have to program a D. So whenever you activate G41, there has to be a D value. Otherwise, the machine's going to compensate how much? Nothing. You're going to scrap your part. Right? So always move to a clearance position, always bring the Z down, and always program a D. D for diameter. So let's go back to our program that we just did. Let's look at tool number 4. At the top, we've got T4, M6. What is that going to do? Change to tool 4. Then we move to X 1.875, Y 1 inch. Where is that? That's the clearance point, right? That's off the workpiece. Then we bring the Z down. You've always got to bring the Z down before you activate it. And then when we move to position 2, we need to activate cutter cop. So you're going to put at the beginning of the line G41. Why are we using G41?
Because it's
You
left.
want a climb cut. G41 means your climb cut. Whenever you program G41, what else do you need to program with it? G. Number 3, what does it say on number 3? A D value. Diameter offset. Which diameter offset are we using? D4. The tool number, height offset number, diameter number should always match. T4, H4, D4. You do not tell the machine the diameter.